Hello there. Welcome to Drone Technology course, Module 2, Tools and Concepts of Drone Design. Today, I need you to see my displays better than you see me. At the moment you would see this de Havilland Beaver, you might wonder why it's doing belly up. Before I really get into that, I would show on this other display, you would see, you might wonder what is that person doing. So let's start on this module. In fact, he is demonstrating part of what Professor Vijay Kumar from University of Pennsylvania, it's a genius on these drones and robotics. I did his course aerial robotics, and as for me, because I do not have college level mathematics, that means no calculus, no trigonometry, no algebra. So I didn't have the stomach to handle this course. But Professor Kumar is doing a magnificent job in this display. At least the presentation, also the whole course, because bringing in all the mathematical equations and explaining how to design drones to do whatever you want to do. So it's let's see if I list out on his presentation. I would, let's see whether we can get this camera a little better. Okay, it's not that great. Okay, now it's a little better. Now, if you don't mind, I have to stick to this clipboard thing. I'm not that good with teleprompter. Have you heard the word drone swarms? That's collision-free movement of drones without bouncing to each other, to fly on different formations and collecting different information from variety of angles, or operating collectively to do one task like lifting a weight, where one drone cannot do. So Dr. Kumar explains how creating agile movement, and he goes on to explain, as a matter of fact, position controller, attitude controller, motor controller, rigid body dynamics, angular velocity, gather momentum, twist the body to go through the window. I think we just saw it over here, and in other words, it's over here. It goes into one. The drones, about 20 of them, flies in 8-figure formation, and then it changes to single file, go through the window, and then again it comes back to the previous position. Let's see now. Give me a moment. Let's see. Oh yes, let's try this one. Okay, and of course he explains to understand the dynamics of quadcopter and implementation of equations, motion, trajectory planning, simulation, kinematics, dynamics, derivatives, primitives for positioning, velocity and acceleration, 3D quad rotor control, second order, stable, marginally stable, unstable. All those things he explains. The thrust to weight ratio, and payload calculation of payloads. That's also we are doing it with that's the weight to thrust ratio. We will be doing it on the next module, that is assembly module. Then he goes on to explain agility and scaling, quickly stopping, mass inertia, the smaller mass, better agility, acceleration, to accelerate quickly and roll and pitch quickly, reverse pitch generation, reverse thrust, dynamic simulation, stopping distance, effects of size, rotation, metrics, nonlinear controls, velocity, acceleration, jerk, snap coefficients, hover stability in wide range of angles, sequential control, linear control, for hover attitude only control, nonlinear trajectory controller, and initialized planning from trajectory, and a whole lot. So then I do all that, then I have to ask myself, where is the money? And yes, I keep asking, where is the money? Because in this course, what we want to do is not to get graduated and get your master's and get your doctorate. The money is coming at a very far end. But what we want to do is to make you make money right now. So in other words, you design something and then go into assembly, go into production, print your instructions manual, do the beautiful package and get it to the end user's hand, and that is the only time that your account will see money. So also speaking of operator manuals, there's another supplementary income somebody can do. I think most people would have experienced. We get all these nice gadgets from China, but if you try to read the instructions, I'm not even talking about the grammatical or spelling error or things, but it's evidently you see that what they have put down on the instruction manual is not what exactly they meant. So on our links list, on the link page, we have listed a number of links to the manufacturers of China and much more you can find. If you can get a way to communicate to them, tell them your gizmo is very valuable, very beautiful, we love it, but the instructions manual, can I write it to you and here's my charge. So that's another way of income. And on the design part, there's one more thing to remember is, if you design things, you don't want anybody else to design, because back in my days of aviation, they used to call it, if the aircraft is flying today, that is already old, because another aircraft much more advanced is already on the drawing board. So this really happened to me many years ago. I was doing this network wiring, and you are always in the basements and where the light level, illumination level is very low, and to do the job holding a flashlight with one hand was a big problem. And remember those days this was not available, only the mine workers had the headlamp. It was like what, $100, $80. I must design one, and I wait on it. Didn't really do the job. Now look at this. This has this angle also. Now I get this for $3 in Micro Center. So no chance making money with that. But this comes handy when we do on the next module, when we do assembling. So always see whether somebody else is designing. So, that's important too. And to take the stand that whatever you design, of course, with the simulation capabilities, what is there today, there's enormous ability and the facility that you have to do your testing, thorough testing in the simulation mode. rather than putting money in the hardware side and spending a lot of money and spending a lot of time debugging. You can do that, but still to take a stand, okay, the final testing is done by the end user is a good thing. It's for me comes under best practices. Always think like that, because I can give you a couple of examples which happened in my life, not on aeronautics or drones or anything, but with automobiles. So, one time I bought a brand new car. I would not say whether it was manufactured in America or any place else. It was fine, except if you go over 60 miles per hour, on the all the windows are up. Of course, you can keep up with the air conditioner on, no problem. But when you pass 60 miles per hour on the driver's side window shutter, if it is in British terms, there comes a whistle, an annoying whistle, and you cannot even you cannot drive even with the radio on or not. That's so not it's like a torture. Okay, so then I contacted the dealers, manufacturers, everywhere. They couldn't even tell me whether it is a defect on this car or a model defect. They couldn't tell me. So end user only found it. Once again, it's not me, my friend's car. On the driver's side mirror, if you drive in the night, you've got a total image of the dashboard on the driver's side image mirror, and you don't see anything. Once again, end user. And this other thing, I think I have experienced every time that if it is a sedan car, after the snow, you clean all the snow and nothing to be seen. But anytime you open the boot or trunk or dicky or whatever name, you open it up, and a slate of ice water gets in there or snow gets in there. Once again, sometimes however much we try, only the end user find there is if there is some defect at times. So my only word is to be alert on that would be a good stand. So now we were talking about that, now then what is there left for us to develop and make money? Because if you think about drones, the number of things that it can do, it's it's tremendous, you know. So how about this if I suggest, see the beautiful flag post that you have in front of your house? How about designing a charger on top of that to go on top of that flag post? Well, somebody else's drone comes, needs some juice, go up, and it will land on there, get it battery charged. Also, the owner of the drone's credit card would be charged, and you will get money to your account. Similar thing could be done with, if you can design an airborne drone where you can charge another drone. For example, let's say somebody else's drone is going from point A to point C, and you're within point B somewhere around in the middle, and you send your drone out. So and because that other drone is running low on the battery, you can piggy bank that drone, take it to the destination. While doing that, you can charge its battery. Once again, money in your pocket. So two items. And I would say underwater drone development, there's a lot of potential there, because what is available today, no doubt there are drones available, but very, very exorbitantly expensive. So there's potential on that. And speaking of underwater, how about all these drones that lands, the drones that land on water? Because for the most part, for people go for nice scenery, there is water. So and just if you can develop a floating plate, if it lands on water, it will float for a while. And if not a plate, floaters on the legs of the drone, and thereby, and also for the motors, if you it won't be really cost effective, because not only cost effective, the weight might become a humongous problem if you try to water seal the motors itself, but you can design just a cover so that it will protect from water splashes at least. That's another thing you can design. And on lost drone, talking about lost drones, how about like quote unquote drop dead battery even would have some use, and if an emergency or SOS signal could be sent out, that will be very helpful, and that will be very marketable if you can keep the price low. And also, what I found, something I learned while I was surfing in the web, was the hybrid firefighting drone. And as you know, the tallest building is no more in America, it's in Dubai, and a couple of years ago there was a fire in this building, and Dubai gave a contract, I think, to one of the Chinese companies. I would have that link also. It's MMC, to design a hybrid drone, like to fix it up on the end of the water hose of the fire brigade, and then it'll go on with its motors, battery power itself, and then it can the hybrid can take over with the pressure of the water. Very nice thing if you can design. Very really versatile. Say no more with that, right? And okay, simulators for quadcopters. Yes, now we are, even for this very expensive hobby, they are talking about the machines that are worth more than $1,000. So if you can develop a very good simulators where they can fly it, and that simulator, if it is good, if it is adaptable to different designs from different manufacturers, there you have your money, I believe. And when you do design that, you can go one step further to give the option for a helicopter simulator. In effect, what is available today are really expensive. And another third level of that, if you can design physical control columns like in an aircraft or a helicopter, which you can plug into your smartphone or your laptop, that's another money-making idea right there. Accessories and power lines. For power lines inspection, we already know power lines inspection is being done by drones. But if you can design any attachments that the drone can carry up there to do the job, maybe tightening the cables or spraying for corrosion, anti-corrosion stuff or whatever, where down below the operator with the FPV can look at it and operate that. Another idea. So we will continue on this module. Let me show you one other thing. Give me a moment. Yes, ladies and gentlemen, I have to emphasize, if you want to make money, do not reinvent the wheel. So we have to find new innovations and novelties, as I said. I also want to bring your attention, like if the United States keep enforcing any importers, any developing country importing products to United States will have to stick by the basic humane standard. In other words, basic living conditions in their work sites. So if you do that, let's take this reality. Let's face this reality. The cost of making a product in United States not going to be par with developing countries. That's not going to happen. But the gap is going to shrink. And coupled with the idea, bring back low manufacturing jobs to America. Aren't we doing the same over here? So let me not get distracted too much onto that. I'd like to think, at least I would like for you to think about remote printing. I want to make a comparison here. I really selected printing because printing always does something mechanical. Let's say your wireless router, you are sending printing jobs out, no physical connection, but you get the print out. And going a step further with the Google printing, you could be in the bus or maybe in the train. You can send a job out from your smartphone. And what does the printer drags the paper and prints on it with the inkjet or laser and spit it out. That means a mechanical thing happened. And with your remote, just handling your phone. So on drones, to think about all the remote actions that are happening, always think the technology that you can, with sending out signals, you can do a lot of things, mechanical things to happen. And once you think that as the basis, it makes you, it's at least make it easier for you to understand all the activities that goes with the remote control and your drone. Of course, there's one whole chapter on the remote control, but I brought it up so that I get you into the mind frame to understand the concept. And also, I want to put the clock back, the earlier model aircraft. Of course, they didn't have the battery, they were not really battery operated, but tiny combustion engines. You had only 3 controls and 3 frequencies. One, you accelerate and reduce the speed of the engine, and then you had the left turn and the right turn. That's pretty much it. But now with the FPV, first person view, not only before you had your control is the transmitter, you transmit the whatever the action you want, and your aircraft obeys. But here now we have two-way. You transmit to the drone, it does the activity, it obeys your activity. Not only that, it has a transmitter too to send you back the pictures, the photos. So it's a two-way thing now. And okay, now I promise about this the Hawaiian beaver, why it's belly up. In fact, what really happened was this was a demonstration by MATLAB again on Simulink. This smart lady engineer, her name is Becky Pates, I think. Hopefully I pronounced her last name properly. An applications engineer. What she was demonstrating was how to develop an autopilot actuator to control the ailerons of the airplane. And then as soon as she put the flight gear up, and unfortunately the plane came belly up, and you know, while the lecture was going inside the lecture room, in front of the audience, she managed to clear the bar. Congratulations, Becky. And let's think back. How did she do that? What facilitated her to do that? It's the advancement of this program, Simulink. and sim mechanics also. And all what she had to do was started debugging step by step. Only a few steps she had to go through because of the advanced scope and uh, different points. You can check the scope and see the waveform, and to find the original designer um, negated the gravity and he forgot to put it back. So, what can we take home with that? Number one, of course, on which planet we can take out the gravity and put the gravity on whenever you need it. That's one thing. And the capability that is given in the Simulink and SimMechanic program to debug, and how with this advanced scope it has made it so easy. So there you are. And coming up to the same point, I would also say why I stick by MATLAB rather than the any other program, maybe SolidWorks or Octave is a free program, but MATLAB I think has a solid support. So when you are developing something for material for money gain, we have to make sure that there's enough support. Otherwise, you're going to have problems. And also there are so many new words that I'm coming and I'm going to introduce, but I don't want to scare you away. But all those new words, now you will know the figure, how we coordinate with the figures. Like from last lesson, every time I refer to a figure, there's a figure of module number and figure number. And on this module 2, figure 2 is the glossary of all the words, and module 2, figure 1, there's a whole text of the audio, so you can look at it. And let me say this, going into a little bit more on Simulink and Simulink and sim mechanics. Will introduce number of right. That's the other thing is. Let's start with this algorithms. Like you have to, at the very outset, you have to do algorithms. And what are algorithms, if I may ask? Let's try to understand that word itself. And in a better way is to ask, what do you use algorithms for? And once again, another demonstration by at least MATLAB by Mr. Rand Gordon. He gave a very simple explanation for algorithms. We are getting something to do something. So that's pretty much algorithm is. So that's a very simple way to look at it. Yes, all the time we develop algorithms for that purpose. Get something to do something. Then once you develop your algorithm, once you define your algorithm, you should match it up with the system needs and totally run in simulation mode before you get on to spending money on hardware. Again, additional testing on hardware, real life testing, and if it meets all client needs, you are ready for production. And let's talk a little more about MATLAB, Simulink and sim mechanics and SimScape. To make let's try to make an analogy, how to understand how this works. Okay, and in fact, this picture is already there. You got MATLAB, Simulink, and SimScape. On the SimScape, it's a multiple package thing. In this event, we are using Sim Mechanics, but it also has Sim Power Systems, Sim Hydraulics, Sim Driveline, and Sim Electronics. So those are additional. If we imagine it this way, that will be the ideal. To make the analogy and to grasp it easily, MATLAB is, let's consider MATLAB as the base platform. On that, Simulink runs on that, and then Simulink becomes the platform for SimScape, on which a part of it is Sim Mechanics. Then let's discuss a little more, at least try to discuss this. Why model-based design? Firstly, it helps to have a better understanding of the process that you are trying to develop and cut down complexity and the time. And there are many advantages of that. Like there are many. For now I only mark a few. Early verification is one, and there's a performance advisor. That again, very helpful tools when you get on to the job and you want to get the thing running. Start your development stage by stage. These things becomes very helpful. And you got the model advisor, model blocks. All those features come in very handy. And one other thing, if you want to distinguish between Simulink and SimMechanic, Simulink, the flow is one way, except that you can have your feedback loops. As against SimMechanic is two-way flow. It's bidirectional, so that's one of the major differences out there. And then on SimMechanic, the ability to import CAD models and modify it and tune it and optimize it. Optimize is also yet another very important feature. That means you are looking for a particular waveform. You are not getting that, but you are getting something close. And then you go on the optimizing feature, and it will try to get as close as possible. And you might be able to work with the best waveform that optimizer develops, or else you might have to adjust hardware or whatever adjustment that you have to do in your designing. You can still do that, but the life has optimization has made your life much easier at that stage. Okay, and let you develop the much less, and that let you a lot of time in your hands saved. SimScape enables multi-body simulation of 3D mechanical systems. Multi-body ones, okay. And let's say quadcopter simulation presentation. In the quadcopter simulation presentation by once again Ryan Gordon, he puts in to the control output the pitch ratio and pitch command. The correct word is pitch command as the final output, and then roll command, altitude command. But he left out the yaw to make it less complicated, to keep it simple. We really changed the diagram. We put in the yaw also. Then you can see it on module 2 in figure 13. And I'm sorry, module 2 figure 4. And on module 2 figure 13, it shows how you import from SolidWorks. It's a simple drop down menu. CAD tools, export, Sim Mechanics. How much more simple can it be, right? And I want to talk a little more about this advanced scope, because uh, the, this kind of a feature for the older programmers, they're gonna adore this. Uh, it makes it so user friendly for you to bring in your scope at various levels and check the waveform and do the necessary changes, or retune and use the retune button to maximize it, optimize button also there to maximize it. Between the two, you get as close as possible for the waveform that you are looking for. And again, I have to emphasize again on this play button. They call it play button. It's practically the run button. Every stage, you can make a run, and it also has a feature. When you run it at one stage, if you are not satisfied, you can move it back on reverse, on rewind. You can go back and make sure you are satisfied from there onwards, and then you can work up. And it's no doubt it also has a forward button, so you can if things are going fine, you can go or you can take a leap forward and check the development at a later stage. So that is possible too. So these features are coming very, very handy and making life very, very easy for the developer. Features that you could never have dreamt of a few years ago. Yes, on play, every time the values are changed, helps debugging easy. Also, other tools to analyze system errors, look for existing errors, correct them every step of the way. Wow! So it's so nice. And then sensing and communication, compute sensor models / blocks, control algorithms. Like it allows, like in the hardware case, it allows. You have your output going in taken from USB. You want to change it as against Bluetooth. You can the algorithm change can be done on that. Yet another good feature to have. Then utility functions incorporating state flow, and another subprogram more applicable in component level standpoint. That's the state flow. Okay. Standpoint. Working with Simulink facilitates early verification and validation and observing changing dynamics. So there you go. And all this with model-based design as against code-based configuration parameters. Adapt the design for Simulink data inspector allows to. I want to go slow with this one. Adapt the design for the Simulink data inspector allows to log in, record, save, and inspect signals, and makes it possible to check on content and preview dialog boxes. Wow. So all in all, Simulink multi-body simulation environment for 3D mechanical systems can simplify building up dynamic systems. You can integrate with other modeling libraries and library blocks without deriving equations. Oh, what a pleasure is that. It's like godsend. Making the environment useful for directly importing Fortran, C, and C++ without equations. That's the real way to go, and that facilitates a lot in terms of design. And you have portability from code base to Simulink. Once again, helps out in a big way. Model-based design gives the ability to 3D CAD imports. So those are another nice feature. And I have a little more things on this module, tools and concepts. We're going to talk about hertz and cycles per second and NTSC and PAL on when it comes to camera functions. And one other thing, I do not want to miss this 6-DUF joint. In fact, joints are listed in three figures. I have the figure numbers. I'll have to give it out also. And do you see this? Let me move the camera a little closer over here. Okay, let's see. Yeah, this 6-DUF joint, 6 degrees of freedom joint. That's something very important. You see translational degree of freedom and rotational degree of freedom. It's out of all the joints that you will be dealing. That is also very important. That's the primary important joint you'll be dealing with when you are dealing with drones. Okay, to continue, I feel like my head is only half seen, but in a way it's better considering the age. I'd rather see nobody see my head at all. But let's get into the subject proper. I want to do a synopsis on model-based design still, like run through a few more highlights. Some of them I already mentioned. Control design, automatic code generation and automatic code verification, very important things. And in and out subsystems. Remember the comment option. You have to your subsystem. You can comment in or comment out as you go on developing your program. And once again, continuous and discrete time testing. When you we discussed how we can go back and forth on play, rewind and forward. So that's again, we are trying to recapture those moments again. Linear transfer of functions to existing C code to high fidelity model. High fidelity model. That's another good feature. Simulation data inspector signal properties. We did talk about data inspector even before. Log signal compare runs. One other thing I definitely forgot to mention on the model blocks, you have the input side you have marked as the base port, and the output side is marked as follower port to make you into how the blocks work, but to remember that is also is a good thing. And of course, subsystem code generation report allows you to get a header file, okay, and input output reports where a software developer can develop that separately to cut down the complexity. That's, once again, real good features. And there's another called reference advisor, which will create model referencing, and then you can do tracing between model and code through code generation report. That's again we touched even earlier. Static code metrics, continuous time and discrete time, and even test harnesses could be continuous. Could be subjected to continuous testing or discrete testing. And ESC, electronic speed control, will be dealing that on the assembly in an elaborated way, so we'll leave that alone. And at the end of this module, I'll run through as a recap all the figures, and we'll discuss that also in a summary form. But how am I going to complete this concepts and tools module without talking about the PID controller function? PID controller function, you can do block parameters. This block implements continuous and discrete control algorithms and includes advanced features such as anti-wind-up, external reset, and signal tracking. You can tune to adjust PID gains automatically using the tune button. That requires simulating control design. Well, PID, once again calculus. For me, it's like a poison pill, but there's a silver lining. Of course, PID stands for proportional integral derivative, but let's look at it in the drone arena, drone life, in a different way. In the sense, let's think P is the power. Let's say on your motors, if the motor speed is trying to recorrect itself, PID P value, if you can keep it to 200, it's generally accepted. It runs good, and we'll talk about the I value later. And once you have the proper P value, it will run the drone without trying to. The motors will not try to perpetually correct itself and give a vibration once you have the proper P value. But then, of course, you take your drone out, it's exposed to the laws of nature, just the wind. If it tilts this way with the wind, it has no way of, its correction method may be not that smooth, and it may not even get into the correct position as you want. So that is handled by the I value. So you keep maybe 10% less of the P value, you adjust the I value, then for the wind or any external factors, if the drone tilts to one direction, with the I value, it can get it back, to the proper position. And then how about D? Let's think of D as damping. Let's say you take an aggressive turn, and you want to be aggressive, you're going to be quick, but at the same time you do the D value, meaning inject a little drag, so that as you do the aggressive turn, it also get back as soon as possible to the level that he can do the flying with in a smooth fashion. So that's pretty much about the PID in layman terms. But one other good thing about PID, it's more like once you get hands-on, you get used to it, how to adjust the P value, I value, and D value. The thing is, you may not be able to explain to another person how you adjust, but it's still once you get the knack of it, you would really get the knack of it once you keep using it. All right.